Hello everyone, I'm Michael Dominic Signetes together with my co-members Miss Patrice Jane Hundaya, Erica Mariel Tonzo, Marcia Barquilla, Gary Suarez, and lastly Miss Nicole Manding. And today video presentation, we're gonna discuss about the iodine number, the use of fats in the body, and lastly the physical properties and chemical reaction.
Hi, this is Carrie and let's talk about iodine numbers. Iodine numbers are also called as iodine value. They are the measure of the degree of unsaturation of oil, fat, and wax. It also refers to the amount of iodine in grams that is taken up by the 100 grams of, once again, the oil, fat, and wax. Saturated oil, fats, and waxes take up no iodine, therefore their iodine value is 0, while the unsaturated oils, fats, and waxes take up iodine. Their iodine value will only depend on their amount or how much iodine it contains. Unsaturated compounds contains molecules and double or triple bonds, which are very reactive to iodine, and that means that the more iodine is attached, the higher the iodine value, and the more reactive, less stable, softer, and more susceptible to oxidation and rancidification are the oils, fats, and waxes. If you are thinking what is the normal range of iodine value, then here's the answer. The iodine replete healthy adults has about 15 to 20 milligrams, 70% to 80% of which is contained in the thyroid. Then, in the children and adults or normal adults, it indicates median urinary iodine concentration of 100 to 199 micrograms per liter. And then, in the pregnant woman, it has about 150 to 249 micrograms per liter, and greater than 100 micrograms per liter in lactating women indicates that the iodine intakes are adequate. Now we have here the Wedge's method, which is the most popular procedure in the iodine value. But aside from that method, all other methods suppose that a normal carbon-carbon double bond takes up 2 atoms of iodine. Apart from the number of double bonds present in the molecule, the IV or the iodine value is also influenced by the molecular weight. As you can see on the screen, those are some examples of IV or iodine value and its equivalent. So first is the IV oleic acid, which is equivalent to 90.1. Then the IV glycerol, which is equivalent to 86.2, trialine similarly. Then the IV linoleic acid, which is equivalent to 181, and it's trilinolene, which is equivalent to 173.2. Then lastly is the IV linolenic acid, which is equivalent to 273.5. Its trilinolene is equivalent to 261.6. Where several fatty acids are present, the IV alone cannot give a detailed picture as to how much IV and therefore potentially reactive and stable oil is present in the mixture. Now take a look at the screen, for I'll be showing you a table. So that table contains the reported values of oils and fats and its iodine numbers and normal ranges. So for example, as you can see, there is the coconut. Its iodine number is in between 11.3 to 1.20, and its normal ranges or normal range is about 8 to 10. And that's about it for my part. Now please listen to Ms. Krill Manding to know more about iodine numbers.
The iodine number indicates the amount of unsaturated fatty acids present in the product. Here are 2 facts about iodides in soap. So 1. Soap made with mostly unsaturated or liquid fats tend to have high iodine numbers. 2. Soaps with the mostly saturated or solid fats tend to have lower iodine number. So what is the importance of the iodine number? So the most important application of the iodine value is to determine the amount of saturation contained in the fatty acids. So the unsaturation is the form of double bonds which reacts with the iodine compound. So the higher the iodine value, the more unsaturated fatty acid is present in the fat. So it is important to know iodine number to be able to balance the amount of iodine to be intake by the individual.
So hi everyone, by the way, I'm Erica Tanzo. Before we proceed to the uses or functions of fat in the body, let me first introduce to you what are fats. So what are fats? Fats is one of the macronutrients along with carbohydrates and proteins. It is found in the most food as it is essential part of a healthy diet. Some food have a high fat content while others have just a small amount. Fats has a three-carbon backbone called glycerol, as well as fatty acid chains or the triglycerides. When we say triglycerides, it is a three-molecule structure joined together. The fatty acid chain is basically a string of carbon and hydrogen atoms. When an OH from the glycerol molecule binds to an H from the fatty acids, an H2O, a water molecule, gets released and the two molecules link up. So if this happens once, the result is a monoglycerides. If it happens twice, it is a diglycerides. If it happens thrice, it makes a triglyceride. So what are the different types of fats? There are two general types of fats. We have the saturated fats and the unsaturated fats. Unsaturated fats has three different subtypes. We have the trans fats, monounsaturated fats, and polyunsaturated fats. To understand fats better, we need to start with the main form of fat, which is the triglycerides. As I mentioned earlier, triglycerides are a three-molecule structure. It consists of glycerol unit and three fatty acid chains. Fatty acids are made up of long chain of carbon atoms and hydrogen atoms. Some carbon atoms are linked by single bonds and others by double bonds. These bonds determine which type of fat the chain is classified as. The first type of fats we're going to look at is the saturated fats. In saturated fats, all of the carbon atoms are saturated with hydrogen atoms and do not contain double bonds between the carbon atoms, and this gives the molecule a linear formation. Saturated fats are usually solid at room temperature and have a high melting points. Foods that are high in saturated fats including pork, fatty beef, cheese, whole milk, eggs, coconut and palm oil, and butter. The question is, are saturated fats healthy? Research suggests that saturated fats affect cholesterol level by increasing overall LDL, or the low density lipoprotein, or the bad cholesterol, increasing HDL, or the high density lipoprotein, or the good cholesterol, and increasing the LDL particle size. But we must note that with any food, it's always about moderation. Now, let's look at the unsaturated fats. Unlike saturated fats, unsaturated fats have at least one double-bonded set of carbon atoms in their structure. This double bond can take on one of two formation. It can be a cis configuration or a trans configuration. In the cis configuration, the hydrogen atoms are on the same side of the double-bonded carbon atoms, while in the trans configuration, the hydrogen atoms are on the opposite sides. Now, let's proceed to the first subtype of unsaturated fats, which is the trans fats. Trans fats are solid at room temperature and usually have a high melting point. There are natural and artificial trans fats. Natural trans fats, also known as ruminant trans fats, are typically make up 2 to 5% of fat and dairy products, and 3 to 9% of the fat in beef and lamb. It has been concluded that a moderate intake of ruminant trans fats does not appear to be harmful. Artificial trans fats are another story. Artificial trans fats are formed when manufacturers turn liquid oil into solid fats through a process called hydrogenation. When we say hydrogenation, it is a process by which the vegetable oils are converted to solid fats simply by adding hydrogen atoms. Hydrogenation increases the shelf life and flavor stability of foods. Artificial trans fats include many fast food items, some baked items like cookies and cakes, fried foods, and steak margarine. So, are artificial trans fats healthy? It has been concluded that artificial trans fats affects cholesterol level by increasing overall LDL and decreasing HDL. It is also linked to an increased risk of heart disease and believed to cause damage to the inner lining of blood vessels. The next unsaturated fats we're going to look at is the monounsaturated fats. Monounsaturated fats have a system electrical atom that is on the same side. This gives a band or kink-like formation. Monounsaturated fats have only one carbon double bond in their molecule. They're usually liquid at room temperature and have lower melting points than saturated and trans fats. Foods that are high in monounsaturated fats include plant-based oils such as olive oil, canola oil, and peanut oil. Other foods include avocados and many types of nuts and seeds. So are monosaturated fats healthy? It has been concluded as generally being good for health, especially when chosen over saturated or trans fats. But it's always about moderation. Any fat can be unhealthy when consumed in unreasonably high quantities. So the last subtype of unsaturated fats is the polyunsaturated fats. Polyunsaturated fats also have a cis molecular formation wherein the hydrogen atoms are on the same side, that also giving it a link formation. Polyunsaturated fats have more than one unsaturated carbon double bond in their molecule. They're typically liquid at room temperature but start to turn solid when chilled. Polyunsaturated fats are generally classified by their omega numbering. The omega carbon is the carbon atoms at the end of the hydrogen chain. There are 4 types of omega fatty acids, which is the 3, 6, and 9. These are determined by where the location of the first double-bonded carbon atom is located. The fatty acid here is an omega-3 fatty acid because the first double bond occurs at carbon number 3. The other omega fatty acids follow the same structure. The omega-3 and 6 fatty acids are considered essential because the body cannot make these foods. High in omega-6 fatty acids include processed vegetable oil, salad dressing, fried foods, and grain-fed beef. Food rich in omega-3 fatty acids include flax seeds, walnuts, salmon, and tuna. So are polyunsaturated fats healthy? It has been suggested that omega-6 can have inflammatory effects and omega-3 can have anti-inflammatory effects. But once again, it's about the moderation intake of food in your body. It is generally healthy as long as you get them from a good source. In overall, most of the fat we need is made by our bodies. But there are some fats our bodies cannot make. We can only get these fats by eating them. Getting enough fat in your diet is important for staying healthy. Eating only very low levels of fat is not recommended.
Hello everyone, I am Patrice Jane Al-Hudaya, and I am here to discuss about the use of fats in the body. So, as Erica has said, fats are one of the macronutrients along with carbohydrates and protein, and it is an essential part of our diet. Fats are found in most foods. Some foods have a high fat content, while others have just a small amount. The fat that you carry on your body has a scientific name. It is called adipose tissue. And even though many dieters would like to reduce the amount of adipose tissue that they carry, adipose tissue is important for a healthy body. Now, what is adipose tissue, by the way? Adipose tissue is commonly known as body fat. It is found all over the body. It can be found under the skin, or what do we call the subcutaneous fat, packed around internal organs or the visceral fat, between muscles, within the bone marrow, and in breast tissue. Now, what are the use or functions of fats in the body? The first function of fat is insulation. There is a thin layer of fat underneath the skin that keeps the body from maintaining the proper temperature. This thin layer of fat underneath the skin is the adipose tissue. Adipose tissue helps to insulate your body. This heat insulation keeps your body warm when you are exposed to cold temperatures. This layer also protects the inner core from extreme temperature changes. Protection is the next function of fat. There is a layer of fat that surrounds major organs, protecting them, acting like a cushion, absorbing shock from any sudden impact. So, what do we call this layer of fat that surrounds major organs? This layer of fat is visceral fat. Visceral fat is fat that wraps around your abdominal organs deep inside your body. Many of the major organs are wrapped in a layer of visceral fat deep inside to protect the organs during physical trauma. The third function of fat is energy production. Fats are the slowest source of energy but the most energy efficient form of food. Each gram of fat supplies the body with about 9 calories, more than twice that supplied by proteins or carbohydrates. Because fats are such an efficient form of energy, the body stores any excess energy as fat. The body deposits excess fat in the abdomen or in the omental fat and under the skin or in the subcutaneous fat to use when it needs more energy. The body may also deposit excess fat in blood vessels and within organs, where it can block blood flow and damage organs, often causing serious disorders. The next function of fat is satiety control. Fat is critical for human health, and it provides satiation, which means it diminishes your appetite. What this means is, if you want to lose body fat, you first control your intake for total calories, making sure that you are eating less than you need on a daily basis. The next thing that you do is that you make sure you have a good balance of macronutrients in your diet. This means a good balance between proteins, carbohydrates, and fats. The fats should be approximately 20% to 30% of your total intake of calories and should contain mostly good for your fats. The fats that are most prevalent in nuts, fish, certain fruits like avocados, etc. The fifth function of fat is vitamin absorption. Fat-soluble vitamins are dissolved in fats. They are absorbed by fat globules that travel through the small intestines and are distributed through the body in the bloodstream. The body absorbs these vitamins as it does dietary fats. The fat-soluble vitamins A, D, E, and K are absorbed from the intestinal lumen using the same mechanisms used for absorption of other lipids. In short, they are incorporated into mixed micelles with other lipids and bile acids in the lumen of the small intestine and enter the enterocyte largely by diffusion. Within the enterocyte, they are incorporated into chylomicrons and exported via exocytosis into the lymph. Hormone production is also one of the functions of fats in the body. Several important hormones, including leptin, are produced and released by your adipose tissue. Leptin is a hormone that sends signals to stop eating. When the body is functioning properly, excess fat cells will produce leptin, which will trigger the hypothalamus to lower the appetite, allowing the body to dip into the fat stores to feed itself. Now, to sum it up, fat is vital for life. It insulates the body, protects the organs, provides energy, helps with satiety control, vitamin absorption, and hormone production. Fats are important nutrients that should be an essential part of your diet. Thank you.
Thank you for that very informative reports, mates. Now, let us proceed. But first, let me introduce myself. By the way, I'm Michael Dominic Signatas, BS MedTech student. So, have you ever wondered what is a physical properties? Well, in characteristics that enable us to distinguish one substance from another are called properties. A physical property is a characteristic of matter that is not associated with a change in chemical composition. Familiar examples of physical properties includes density, color, hardness, melting and boiling point, and also electrical conductivity. We can observe some physical properties such as density and color without changing the physical state of matter. Are you excited? Now, let us proceed to my video presentation for further information. As we observe the materials in my desk, there are deodorant powder, vitamins, clip, and a marker. In order to determine their physical properties, the first thing first is the density. Which of the objects are light and heavy? The deodorant powder and the vitamins are heavy. Then the clips and the marker are the light one. Very good. We sort them out according to their density. Okay. And now, what color among the four materials are white and green? Let's find out. Very good. In order for the objects to be classified in their physical properties, we both sort them out according to their set of colors. which are green and color white. And now, let us continue. Let's go. Other physical properties such as the melting temperature of iron or the freezing temperature of the water can only be observed as matter undergoes a physical change. Now, how about the physical change? Did you know what is physical change? Let's find out. Blending a smoothie, for example, involves two physical changes: the change in the shape of each fruit and the mixing together of many different pieces of fruit or ingredients. Because none of the chemicals in the smoothie components are changed during blending, we know that no chemical change are involved because the water and vitamins from the fruit are unchanged during this process. So, you know, a physical change is a change in the state of properties or properties of matter without any accompanying change in its chemical composition.
Good day to everyone. This is Marcia Barclia, and today we are going to talk all about the 5 types of chemical reactions. As far as you can remember, what are these 5 types of chemical reactions? If you guessed it correctly, those are combination, decomposition, single displacement, double displacement, and redox reaction. We have the combination. So combination is a two or more substances combined to form a one substance. So let's take a look at this example. So in this example, we have substance A and substance B. So substance A plus substance B is equal to one product. So substance A and substance B is now combined, forming into one product. So remember, two or more reactants but one product. So these are the reactants and this is their product. Let's take this as substance, the H2, and this will be the O2. When combined, it forms H2O or water. So hydrogen and oxygen combined together now forms a water. Two reactants but one product. So this is the combination. Let's take it from the elements. So this element is Mg or magnesium, and this one will be the oxygen. So when combined together, this would become magnesium oxide, MgO or magnesium oxide. So the elements is the reactants and the compound is their product. So remember, the key point to this combination chemical reaction is that it has only one product. Two or more reactants, but only one product. So the next type of chemical reaction is the decomposition. So take note that this type of chemical reaction is the exact opposite of what we discussed earlier, the combination. Because decomposition is a one compound breaks into two or more simpler substances. So it is an all the other way around of the combination. Okay, let's have an example. So let's take this substance AB. So when substance AB is decomposed, it breaks down into simpler substances. So it will become substance A and substance B. Okay, from substance AB decomposed into substance A and substance B. So that's how decomposition works. Okay, another example, let's have this substance is the H2O. Let's have this as an H2O. When it is being decomposed, it goes on an electric current. It would become H2 and O2. So now this process is called, when H2O is being decomposed, this is called electrolysis. Now electrolysis is when the water is goes through the electric current to break into hydrogen and oxygen. So remember, one reactant and two products. Try to visualize the digestion of food. So so when we digest food, what does the food that we eat in our digestive system becomes? So it breaks down. So like for example, here we have this reactant as carbohydrates. So when it is being intake in our body, it forms into simpler substances. So like the glucose. And for example, the proteins, the reactant proteins, when it is being digested, it becomes amino acids. So remember, the decomposition breaks down complex to simpler substances. So the key point to this decomposition chemical reaction is that it only has one reactant and it breaks down into two or more simpler substances. That's what you need to remember about the decomposition chemical reaction. Now let's proceed to the single displacement reaction. Now this type of chemical reaction is that the more active the element is, it displaces the less active element. Now let's have an example for that so that makes it easier for you to understand. Let's say we have element A and element BC. Now here we have that the element A is more reactive than element B. What we are going to do is that the element A will displace the element B. Here's what's going to happen. So now the element A is displacing element B. So it will now become element AC plus element B. You remember, the more reactive the element is, it will displace the less element. That is the single displacement reaction. So how do we know that which one is reactive, more reactive, or which one is less reactive? The answer is, it is through the reactivity series.
Metals on the top are more reactive, and as you move down, the reactivity decreases. For example, if you look here, sodium is more reactive than iron. Hydrogen is also in this list, even though it's a non-metal, because it's electropositive in nature and can be displaced by metals. There is also a reactivity series for non-metals, the halogens. This is what the simple reactivity series for important halogens looks like. Fluorine is the most reactive and iodine is the least reactive.
Let's have another example. Let's say we have zinc plus hydrochloride. Now, in the reactivity series, zinc is more reactive than the hydrogen. So, zinc will now displace the hydrogen. So, it will become like this. The product becomes like this. So, it now becomes zinc chloride plus hydrogen. So, let's say we have potassium iodide plus chlorine. And now we have that the chlorine is more reactive than the iodine. So the chlorine will now displace the iodine. So the product will become potassium chloride plus iodine. So remember, the key point to this single displacement chemical reaction is that the more active the element is, it will displace the less active element. And then we have the double displacement chemical reaction. Now this type of chemical reaction is that two compounds react with each other and exchange their ions to form two new compounds. Okay, so that is the double displacement. Okay, let's have an example for that to easily understand what I'm trying to say about the double displacement. Let's say we have compound AB and compound CD. So, in this reaction, two compounds will exchange their ions. So, compound AB and compound CD will exchange their ions. So, the product will become like this. So, the A and the C will exchange. Ions will exchange. Now, this will be the two new compounds. So, compound CB and then compound AD. So, that is the double displacement. So, in this double displacement reaction, is there a reactivity series used in the reaction? The answer is no. The double displacement does not use reactivity series because reactivity series is only for single displacement. The reactivity series is used when it is displacing an element. Now, what in this double displacement did was both of them exchanged their ions. So it is not just compound AB or compound CD, but both of them have exchanged their ions. So there is no reactivity series being used in this type of chemical reaction. Let's say we have a silver nitrate or AgNO3 and NaCl or sodium chloride. Now in these two compounds here, I'm matching it with this. So here what we're going to do is that the silver nitrate and the sodium chloride will split their ions. So that now we have Ag, a cation, NO3, an ion, Na, a cation, and Cl, an anion. So now let us try to exchange their cations. So Ag and Na will now exchange, now forming two new compounds. So now we have NaO3 or sodium nitrate and AgCl or silver chloride. Let's say we have NaOH or sodium hydroxide, HCl or hydrochloride. Now let's try to exchange their ions. Let's exchange the H and the Na to form a compound H2O and NaCl. Here is called neutralization because the NaOH is a base and the HCl is the acid. So the NaOH is neutralizing the HCl to form a water, H2O, and a salt, NaCl. Let's say we have a lead nitrate or PbNO3 and potassium iodide or Ki. Let us try to exchange their cations, the Pb and the potassium, the lead and the potassium. And now we are going to get potassium nitrate and lead iodide. So lead iodide is insoluble in water, so it precipitates. So this is called a precipitation reaction. Since it is in yellow, so it precipitates yellow. The key point in this double displacement chemical reaction is that two new compounds exchange their ions, either cations or anions, to form two new compounds. And lastly, the final type of this chemical reaction is the redox reaction. So redox stands for reduction and oxidation. Now, in these terms here, it means one substance is being reduced while the other substance is being oxidized. So, in simple terms, oxidation means the addition of oxygen, while the reduction means the addition of the hydrogen. But there are also some ways, other definitions in defining these two terms, the oxidation and the reduction. So let's learn them now.
Oxidation is addition of oxygen and reduction is defined as addition of hydrogen. Oxidation can also be defined as removal of hydrogen and reduction is removal of oxygen. Now, oxidation need not be only addition of oxygen. We can expand the definition to addition of any non-metal or electronegative element. Similarly, reduction can be addition of a metal or electropositive element. Now we can define oxidation as removal of a metal or electropositive element, and similarly reduction is removal of a non-metal or electronegative element. Oxidation can also be defined as loss of electrons and reduction is gain of electrons. You can remember the last difference with the help of this simple mnemonic, oil rig. Oil stands for oxidation is loss of electrons and rig stands for reduction is gain of electrons.
Let's say we have a copper oxide and a hydrogen. So the product will become a copper and a water or H2O. What happens here in this reaction is that the copper from the copper oxide becomes a copper, meaning it's reducing. It is reducing an oxygen and it has become a copper. And the hydrogen here is now forming an H2O. It is gaining an oxygen. So that means the copper from the copper oxide has reduced into copper, while the hydrogen is now being oxidized into an H2O. So in this reaction, the hydrogen here is helping the copper oxide into forming a copper. So the hydrogen here is the reducing agent, while the copper oxide is the oxidizing agent because it is helping the hydrogen into forming, by giving oxygen, into forming an H2O or water. Let's say we have a copper and an oxygen forming into the product copper oxide. So which of these reactants here is being oxidized or being reduced? Let's take a look at copper. So the copper here is changing or forming into a copper oxide, which means that the oxygen here is added to the copper, forming into a copper oxide. So that means copper is being oxidized. So, but the oxygen here, since it is being added a metal into the oxygen, so the oxygen is being reduced to the copper. So the oxidizing agent here is the oxygen, while the copper is the reducing agent. So the key point here in the redox chemical reaction is that reduction and oxidation, meaning one substance is being reduced and the other substance is being oxidized. So only the reactants gets oxidized or being reduced. Again, the 5 types of chemical reactions are combination, decomposition, single displacement, double displacement, and redox chemical reaction. Now, after you react those chemical equations, Now see to it that you have balanced them after. Balance those equations and you get the right result. Now that is all for my part for this report in this group. Thank you very much for listening.
We know what is a physical properties and what are its physical change. For further knowledge, we engage the properties of soap and its structure. Let's go! Soap molecule. Soaps are represented as RCOONA or RCOOK, depending whether it has sodium or potassium attached to it. Now, it's obvious that this kind of huge structure cannot be written precisely. Every time that is the reason why we represent soap molecules. Using this structure, the ball on the top represents the carboxyl terminal with sodium or potassium attached. This end is called the hydrophilic end or the head region. But why is it given such a name? Hydra is water, as we know, and philis is loving. That means the end that loves being around or being with water. In contrast, this terminal is called the hydrophobic end or the tail region. Phobia, as we know, is fear. That means the group that fear being with water. It is the portion that tries being away from water. Hence, this hydrophilic part which gets attracted towards polar molecules like water is also referred to as the polar end, and it's called the non-polar end as it's get attracted toward non-polar molecule like oil, grease, and so on. And now that we know the typical structure of a soap molecules, we are almost at the end part of our discussion, but we should know what is saponification. A brief overview of saponification is a process that involves the conversion of fat, oil, or lipid into soap and resulting into carboxylic acids with long carbon chains. Let me share with you our knowledge about saponification in this next video presentation presented by our co-members.
Hello everyone, by the way, I'm Erica Tonzo.
And I am Patrice Jane L. Hudaya. We are BS in Medical Technology second year students.
And so for today's presentation, we're going to do a carrot soap.
These are the materials we need. We have knife, measuring cup, essential oil, a carrot, sodium hydroxide, a strainer, plastic cups, filter, a bowl, and an oil. The first step is start peeling the carrots. Chop a medium-sized carrot and blend it with cold water or ice cubes. Use a filter and extract the juice. Then, measure a 1 cup of carrot juice into a mixing bowl. Add 1 cup of water or equivalent amount of ice cube. Adding ice cube will help in preventing from scorching. Then, add 1 cup of caustic soda gradually and mix. Mix without any residues. Then, let it cool down. Then, use a filter and filter the lye solution once it's cooled down. After that, add a 1 cup of palm oil. To get orange shade, add some food colorings. To add some scent, you can use any essential oil. Blend it until in medium trays. At medium trays, pour into the mold. Now, your carrot soap is ready. As you can see, we achieved making 3 carrot soap. It looks like our carrot soap is effective. As you can see, it has bubbles on it.
Good day to everyone! This is Marsha.
This is Creel.
And this is Carrie.
And
today, we're going to make soap.
First step in making soap is you need 2 cups of water, then 1/2 cup of sodium hydroxide. Mix them together. Make sure not to spill anything. Sodium hydroxide produces or exposes hot pressure. So make sure not to spoil anything on your skin.
When making soap, you also need to have 500 grams of vegetable oil or any type of oil and 100 grams of virgin coconut oil. Then you have to mix it all together.
So the next step is to mix the sodium hydroxide solution to the mixed oil. And then mix.
After mixing, supposedly you get a very thick solution or result, and then distribute them into these 3 cups. And these 3 cups is that we are going to put some different flavors or or we will design them into different colors. So the first cup will be calamansi, and the second cup I'm gonna put red coloring, and then the third cup will be blue. After that, we will mix them together. After putting some scents or some colorings in the mixture, let's put them in this molder to mold its shape.
After letting it sit still in for a few hours, here's the result.
And that's how you make